To understand the concept of convolution, I am going with the idea of fireworks. Assume that Deepavali celebration is going on and there is so much of fireworks going on. What is the impact of fireworks on environment? There will be a lot of smoke remaining in the atmosphere. Now, how to calculate the effect of fireworks on the environmental pollution? Why I am taking the example of fireworks? Because the fireworks are sudden shocks, something which is happening for a momentary time, short duration, with a huge impact. And what we can take as the response? We can take the smoke remaining in the atmosphere as a response for these sudden impulses. After some time, let us take after 5 minutes, what is the impact or what is the smoke? How much smoke is remaining in the atmosphere due to this firework which happened from 0th minute to 5th minute. To illustrate this, I don't have any fireworks here. I am going to use the matchstick here, right? So first, assume that this is the 0th minute. So I am taking a matchstick and I am firing it. Now you can see that some smoke is produced from this matchstick. Okay. And in the 2nd minute, I am taking not one, instead I am taking 2 matchsticks and I am firing it. So again some smoke is developed. Now you can see that smoke will not die out from the environment very fast. It will remain for some more time. So you can approximate an exponential decay in the case of a fireworks, right? So the smoke will remain in the atmosphere for some more time. It will slowly decay and it will become 0. Now, in the 3rd minute, I am again firing 2 matchsticks. Now, what is the effect or how much smoke is remaining on the atmosphere? We have to calculate the effect due to 0th minute matchstick, that is 1 matchstick, 1st minute matchstick, that is 2 matchsticks, and 2nd minute's matchstick, that is 2 matchsticks, and so on. So how can we represent it mathematically? Assume that we have f of t as the firework function and s of t as the smoke function. We have to cumulatively add the fireworks or number of matchsticks I have burned at each minute and the smoke remaining from the previous experiments and the current experiment to get an idea about the total amount of smoke remaining in the atmosphere. For example, consider the 0th minute. In the 0th minute, we can see that the smoke remaining in the atmosphere is given by f of 0 into s of 0, where f of 0 is the firework function and s of 0 is the smoke function, right? And f of 0 is the firework, how many matchsticks I have used, and s of 0 is how much smoke which is produced in the 0th minute. Now coming to the 1st minute, how can we write this equation? We can write this equation as f of 0 into s of 1 plus f of 1 into s of 0. So what is the meaning? There are 2 terms. We have to understand these 2 terms very clearly. The first term says that the leftover smoke due to the experiment f of 0 or the number of matchsticks I have used in the 0th minute, that is f of 0 into s of 1. So this gives the previous experiment's effects, right? F of 0 into s of 1 plus f of 1 into s of 0. F of 1 means how many matchsticks I have used in the 1st minute, and s of 0, the smoke is just now created though, so it is s of 0. Now coming to the 2nd minute, how many terms will be there? There will be 3 terms. What are they? They are f of 0 into s of 2. That means in the 0th minute, some firework happened and there is a leftover smoke, that is s of 2. That is f of 0 into s of 2 plus f of 1 into s of 1. So this just now happened 1 minute before, right? The leftover smoke, because of the firework happened just 1 minute before. That is f of 1 into s of 1 plus f of 2, that is the firework happened just now, that is 2nd minute, and s of 0 because just now the smoke is created, so s of 0. So coming to the 3rd minute, the terms are f of 0 into s of 3 plus f of 1 into s of 2 plus f of 2 into s of 1 plus f of 3 into s of 0. So if you continue this pattern, you can also calculate for the fifth minute. The fifth minute is given as f of 0 into s of 5 plus f of 1 into s of 4 plus f of 2 into s of 3 plus f of 3 into s of 2 plus f of 4 into s of 1 plus f of 5 into s of 0. This can be mathematically expressed like this. For example, take fifth minute. If you want to calculate the smoke remaining in the fifth minute, we can write the formula as summation I varies from 0 to 5 f of I into s of 5 minus I. So if you compute this, you can get the smoke which is remaining at the fifth minute. Now if you want to calculate the smoke remaining in every minute from minus infinity to plus infinity, you have to calculate all such values, right? So this is for some discrete events. That is, we are assuming that the fireworks is happening only at every minute. So these are discrete events. Now consider some continuous events like the charge stored in a capacitor. So it is a continuously happening event. So in that case, instead of summation, we can use the integral. And this idea will become convolution integral. The cumulative effect of the summation will become an integral, right? So whenever there is a continuous function or continuous signal, we have to use the integral for the cumulative effect, right? So summing will become integration in the case of continuous time functions and continuous time signals. Now let us deep dive into the mathematical ideas behind these concepts and try to understand what is meant by this convolution integral in a deeper manner.
I hope you got a clear idea about the convolution integral. The convolution integral says that y of t is equal to integral minus infinity to plus infinity x of tau into h of t minus tau d tau. So this is the equation for the convolution integral which we have derived from the impulse response concept. So this is specifically designed for the impulse response, because this is the impulse response, right? And this is the input to the system, this is the output of the system. Now the mathematicians have taken this convolution integral to the next level and they have generalized it, which is known as the convolution integral. So they are saying that for any two signals, there is no x of t, there is no h of t, there is no y of t, right? So that is for engineers, that they leave for the engineers. For any two signal, let us say x1 of t and x2 of t, the convolution will be done like this: integral minus infinity to plus infinity x1 of tau, very carefully observe it, into x2 of t minus tau d tau. That is integral minus infinity to plus infinity x1 of tau into x2 of t minus tau into d tau. If you compute this, you will get the convolution of the two signal x1 of t and x2 of t. To represent convolution, we are using a star symbol, right? So whenever you see the star symbol between two signals, that means we are trying to calculate the convolution of the two signals, right? And the convolution is performed using this integration formula. Because of that reason, it is known as convolution integral.
Similarly, we can understand this from another analogy. What is that? Assume that in 2020, COVID-19 affected the Indian economy. That is the first wave of COVID-19. Assume that in 2021, the second wave of COVID-19 is coming. Now, how it will affect the economy, or what is the effect of COVID-19 in economy, the second wave? So while calculating the effect of COVID-19 second wave in the Indian economy, you have to consider the effect due to first wave also. So because the effect of first wave is not finished, it is still going on, right? The first wave itself affected the Indian economy. the problem related to that is going on, suddenly the second wave is coming. So when you calculate the response of Indian economy in the year 2021, you have to consider the effect due to second wave and effect due to first wave, or what is remaining, what effects are remaining from the first wave, that also to be considered. So this is the basic idea of convolution. I hope you got a clear idea about the convolution integral. What is the meaning of convolution integral?